yo, yo. We'll give people a few minutes to show up before we start the thing. Show some dance moves. That's not how I do it. I don't stand there in front of the camera and show some dance moves. You got to be like kicking actual ass in the moment. Regarding the e-cores, have I installed all BIOS EC drivers and updates? Probably not. I don't know. Like, what even? It's a computer. What drivers am I supposed to get for it? I don't know. Like, I bought a computer. You know what I'm saying? It's not my job to figure out what fucking chipset driver goes on this computer. It's the job of the people who made the computer. Plus, usually that stuff doesn't solve anything anyway, so what's the point? The Windows software for your motherboard literally crashed your computer on loop. Yeah. No, I'm not surprised. Guess when that can't happen? When you don't install it. You hope computers get good again soon. I don't see any sign of that happening or like any reason why it would happen, you know. That doesn't mean it won't happen. It's just I don't I don't see anything that would cause like a reversal of the current trend, if you know what I'm saying. Do you think it's slowly gaining momentum? I mean, I would say that there are more people, there are more individuals counted as an absolute value on board with the idea that software quality is really terrible now. Like, that is true. Is it even as a proportion of, let's say, as a proportion of programmers, is it even more? Because, you know, the field of programming was still growing until like this year, right? May still be growing in like third world countries. So, like, as a percentage of programmers, like, how many programmers even realize this is a problem? Like, last time I tried to give a speech about this, everybody thought I was a fucking idiot. And that was like 2 years ago. So, I don't know. There's no incentive for it to get any better. I mean, yeah, I mean, there's probably small incentives, right? Or there might be quite large incentives in some cases, but it's not obvious that those incentives are there. And so people are not incented. Like, if, if you can't see the incentive, you're not motivated by it, right? It's not really an incentive if it's invisible. Approximately zero of the programmers you work with think there's a problem. Yeah, and I would say that that's typical. So I would say there are more people who are loud on Twitter who are saying this stuff because it used to be just me and like maybe Casey. I mean, Casey's always thought this, but he just wouldn't vocally complain about it as much until around the ref term time, I think, and then he became very vocal about it. Um, but like, yeah, there's some more high profile individuals who say this stuff, but like, does that matter? Is what I would ask. Where is this speech? The one I'm talking about is not recorded. I gave two versions of it. One time to probably mostly Google and Facebook employees, and they thought I was a fucking idiot. And then another time to like, you know, a private event with, these were both private events, but the second one was like just more higher profile, like thought leader people, and they all thought I was a fucking idiot. Like it was unbelievable. So, not all, but the host of the event certainly thought I was a fucking idiot. So, all right. So, we're going to do an inline assembly thing. And this is something that I've wanted to do for years, but it just hasn't been a priority. And like in this discussion about, hey, should we do inline assembly or should we do intrinsics? I think inline assembly is winning, at least for the near term. I mean, maybe we'll do intrinsics also, damn it. But in this discussion, uh, what would I say? I mean, if you're gonna not even do some of the low hanging fruit that could make the inline assembly better, then if you're evaluating whether it's better than intrinsics, it's like, oh, well, we didn't even do some of the stuff, right? Okay. So what happens, you'll see this kind of pattern over and over where, you know, by size, we do different stuff. Um, like if size is 2, because it's like a different assembly instruction, right? But that's kind of dumb because a high level language, we could change these to the new thing. Because in a high level language, like that's a big part of what you do is like, you generate code based on the size. But suddenly when we drop down to inline assembly and we're being explicit about the instructions, we have to do one per size, right? And anytime you have a polymorphic function, which is most of these, I would say, or a lot of them, then you just sort of have this kind of duplication. And sometimes they're obvious, like these are all literally the same thing, but just with this suffix. But sometimes, because instruction sets are messed up, especially x86, sometimes you get, wait, this is what I was thinking of. Sometimes you get like, okay, byte swap of one thing doesn't make any sense, so we don't do anything. Byte swap of 2 works. Okay, wait. But the output has to be the A register, I guess. And then for 4 and 8, it could be any register. But there's some even more egregious examples like, yeah. So like bit scan there's no such thing as bit scan for an 8-bit input in x86. So you can't just automatically do it based on the size. You have to have a special case for 8-bit, right? And 0 extend the input. And then these ones, though, are all just the extension, right? So here's what we could do, though. I mean, for all this stuff, this is all the same code, right? So what you would like to be able to do instead of all this stuff is be able to say the following. If size is greater than or equal to 2 and size is less than or equal to 8, right? You should be able to put all the same code and delete these other two things. And you ought to be able to say something with the size. So maybe we just select the instruction based on size or the type, right? And then you would get rid of all this redundancy, right? And so that's what I want to do. All right. Meanwhile, when I was flipping through here, we still have some use of this Holio here. So let's get rid of that. All right. Just a little bit. Let me exit Steam. It's popping up crap that's distracting me. Exit Discord as well before it could pop up crap that distracts me. What can you do when you know you're right but the world is against you? You just have to win. That's all. You either just have to wait until it blows away, in which case, like until everyone realizes they were wrong, which typically could be between 2 and 10 years, typically, or you just have to show people unignorably that you're right. And the way you do that is by massively succeeding where somebody else can't. Whether that makes sense in your particular context, I don't know. Why in basic.free are there 2 commas? Because of an awesome programming language feature. In fact, I think, we could just do this. Right. Okay. Let's just run the tests here. Let's make sure. So we're going to do some significant work. Let's make sure we're at a clean baseline, right? What did we edit in atomics? Yeah, same thing. Okay. Of unary. All right. So we compiled. We're just running the tests. Hey, people. Watch a hardware researcher from Stanford say the fastest way to speed up modern hardware is software. Well, that's what CPU people used to always say. They used to say, like, dude, you just got to have your compiler do better instruction scheduling and better this and better that. And the compiler people had a very hard time with that. So the hardware people just said, screw it. We're just going to do that on the CPU. And then they won all the benchmarks that way, right? So, see, it's a good thing we're doing this test before we start the real stuff. Oh, that's just an Emacs turd. Dang it. Richard. Why is it dot star? Because it's better. Because your computer runs faster when you say dot star instead of less than less than. Branch prediction accuracy goes up by 6%. The problem is we have 319 viewers. What percentage of people don't know that was a joke? They took away RMS's access to Emacs's master branch? No. No, I'm sure it wasn't master branch because master is against the law now, right? Master is canceled by the same people who canceled Richard Stallman. But I'm just going to say, if you look at the number of times this has played out, where at first there's nothing, then somebody starts something that becomes successful and has a sort of a semi-institution that grows up around it. And then that institution gets invaded by woke. And then the woke people decide that the person who created it all and made it all possible is unworthy and needs to be kicked out. That has repeated over and over and over again. So much so that there's no way to think it's an accident. It's simply not an accident, right? The purpose of a system is what it does. So, yeah. Bro has said some heinous things. I don't know what he said, but I thought this was America, where we had freedom of speech. Are we in Korea? What's happening? He hasn't gotten kicked out. No, he did get kicked out for a little bit. Maybe he's back, but like, he definitely got like deposed. But Mr. Streamer, freedom of speech doesn't mean freedom from consequences. That's my best weasel voice. All right. So this is working. We're going to check in these very small changes, and then we're going to do the real stuff that we came here to do. So we're going to do a little bit of programming, and then before it gets too late, I'm going to make some black tea, and I'm going to try putting some peppermint honey in there and see how the peppermint honey is in black tea. That's going to be our experiment of the night. Do we have a roadmap? There's a roadmap text file that I haven't updated in a couple years, so it'll be interesting to go back there and do that. Peppermint honey, yes. Yes, such a thing exists. I didn't get non-expired milk. We still have to get milk. So that'll happen at a different time. Okay. I did not write the inline assembly system. It was written by a dude named Ryan. And so I'm not very familiar with it. I glanced at it a little bit earlier today for like 2 minutes. So we're going to figure out how to do this. First, I just want to parse. Okay, let's make what we want to parse, right? So let's go back to like bit operations maybe, or atomics, but so byte swap. I mean, this is pretty good, right? Okay. So we're going to call this my byte swap, just so we're sure that we're calling this one, all right? It is a macro. And first, we're just going to make it work before we do anything. So here we're going to assert false. Actually, no, because we're going to want to make this a test eventually. But let's just put a print here. Print, warning, we are not on CPU is equal to x64, so this is not the test of the assembly system we would wish that it were. Okay. 4, 1 to 5. All right, and then we do the byte swap down there. Okay, so we're going to have a 4 byte. Well, we could test it for inputs, right? So we're going to go byte swap test CA. Actually, we're going to all right. So we're going to have a byte swap test, which is value is a $T. We're going to print byte swap test size whatever, value whatever, and size of T, format int, value base is 16. All right. So and then we're going to go result is value. We're going to go my byte swap of value. My byte swap of value, print result. Okay. We're going to return result. So we're going to return T here. Okay, and then okay. And we're going to say assert R8 is equal to OXCA. Assert R16 is equal to OXFECA. Hopefully I got those right. Okay. I don't know. Let's try that, right? Let's try that. Oh, G is not, guys, G is not in hexadecimal. Well, what do we put here? What are our suggestions for what to put here? 6? 6? No, that's not readable. Oh, 9? Eh. Dead beef? No, we don't dead beef. We don't dead beef around here. We don't want bad food. Code. What? I don't like any of these suggestions. Leet code. That has nothing to do. We're in a cafe with food. What is this leet code? No, we can't do 8008 because we'll get canceled like Richard Stallman. Intel 8008. Yeah, it's Intel 8008. It's not something else. Okay, we're going to do the 9. Oh, coffee. Let's do coffee. That's cool. Okay. So today I learned G is not in hexadecimal. All right. Wait. Why are these not in hex? Oh no, they are. We're just not printing result in hex. I'm like, wait. Okay. So we got it right. Okay, so, and we also didn't print our big warning, so that's great. So now, this is the thing, is I want to change this to use our new feature. And at first, I'm just going to do this. Okay. Just on one of them. And now we're like invalid instruction operand. Wait, do we have @ sign already? Wait, what? I wanted to use @ sign, but maybe we're parsing that. Doesn't seem like it. Okay. So, resource specifier, no, parse assembly. All right. So we're parsing the block. I'm skipping past the beginning stuff for now. Okay, we get an identifier. And that's the base ident. And then we could have a colon because it's a declaration. We could have a triple equals. All right. Else, if we're going to do some cowabunga oriented programming, if token type is equal to the @ sign, we'll just even make it a parse error. Cowabunga. Because we just want to know that this is working. No, don't ever show this dialogue. What are you talking? What? Fuck off. Okay. Invalid instruction operand. Okay. Well, that's weird. I mean, I guess the identifier parsing eats the @ sign. And the question is it doing something like that? Like with it, or is that an accident? Like, okay. Wait, but that's my make ident. Wait, no. Make ident peak next token. Oh, you know what? @ sign, we're using the lexer and getting a token, right? It thinks this is like it thinks it's a note. We could put the lexer in assembly mode. And then we would be allowed, if we make an assembly mode, yeah. Let's just do this. There could be some consequences to this, but I feel like it's okay. Let's just try it. So, is this an arrow, actually? Yeah, it's probably an arrow. If lexer assembly mode, then break. Okay, what is assembly mode? False. All right, so now in course, if I do this, it's going to make it more annoying. Because we give people a lexer. What else? Do we have any ideas if we want to not do this? What other token can we use that just sort of means like this is a modifier on this guy? We could use comma. That's kind of weird, but yeah, you know what? Let's not do this. We could, because we could change it later if we don't want it to be @ sign, right? So, like, if I just keep the tokens the same and don't dynamically switch them, that'll make life easier for anyone who wants to make, you know, like an editor for this or something. Not least of which because the meaning of the @ sign would change syntactically as you like delete things and repaste them, and that's not good. So, yeah, let's try a comma. And if we don't like that, we could change it later. All right, so case comma. See, it's a good thing to do cowabunga-oriented programming. What's the point of testing x86 on it? What? What? All right. We're cowabungaing, but we're not even eating the token, so we're infinitely cowabungaing. That's fine. Now if we cowabunga, we will break. Yeah. Okay. So now we're going to do a token. Is it identifier? Token type is not equal to token ident. Parse error lexer token expected an identifier after comma. All right, and then return 0, I guess, is the convention for this function. Otherwise, we're going to say size ident, and then we're just gonna we're gonna drop that on the floor. And so now our code should actually parse, but it will fail because bswap without a size modifier is not an instruction, right? Wait, expected an identifier after what? Eat token. So that's the comma. What? What? That seems straightforward. Mr. Streamer, those are the consequences that we were talking about. Dude, I have such vile emails and DMs from like woke people that I know personally who are just like saying horrible shit about how my life is going to be destroyed. And like, you wouldn't believe, dude. Just insane stuff. For saying things. The most recent one was like, hey, everybody, I don't think vaccine mandates are a good idea. And like, oh, I got the most heinous. Now they're all on Blue Sky. Okay. Probably not a good idea from a financial POV. But does this idea make a good game? Yes, the game is very, very good. Is it the optimal thing to do financially? Absolutely not. Not even close. Not even close. Okay, expected an identifier after comma. Why? What is the token type? 44. Wait, is that comma? But wait, what? Oh, this is peek ahead. Oh yeah, this code is weird. All right, whatever. Why do you do this? Okay, so we haven't eaten the identifier here yet. Okay. So we need to do a thing where we make that the instruction ident. Why? I don't know. That's just the way he wrote this parser. Okay, we get an identifier index. Okay. Base, we're going to call this base identifier because I don't know what to do with these indices. Like, wait, does that eat the token. God, this is so confusing. All right. No, maybe not. Maybe not. Let's just try it this way. Beat the comma. All right, let's try that. All right. There we go. We parsed it, but now it's invalid instruction mnemonic. It's like Johnny mnemonic, but different. Now, why the near matches don't include B-swap with anything, I don't know. There's obviously something a little off about that algorithm. But, yeah, okay. Oh, no, it's T. It's trying to match T, I guess. Wait, what? Let's see which one it thinks it is. Because maybe it's trying to make all the identifiers instruction mnemonics. I don't know. Invalid. Oh, God. Do we have a new... Oh, fuck. I haven't had this problem in a long time. Yep, look, there's a control M in the file. I fucking knew it. Why? I thought that was done happening. I thought someone had somehow magically fixed it. Okay, so this is T. Yeah, it thinks T is an identifier. Why are we down there? Oh, because we didn't do some other thing that we have to do. Oh, these are interesting. Okay, you know what? We're going to move our handling a little bit. Dude, there's so many commas. Where are we? 4,700. Okay, so let's not do this. Here, we're doing this. Yeah, that's not a weirdness. It's called you're looking at the syntax of the main thing. Wait, is that literally why he never did this? Okay, well, maybe we will. This is a better reason to do... It's a better reason to do the thing. The Lexer context sensitive thing that we're talking about. Maybe. Maybe. Okay. So that's another feature that we could do, is just inside Let's just put this back for now. Okay. So if we get a dot, then we get an identifier. Let's be more specific about this. Okay, and we're just going to go, else if token type is comma, we're doing the same thing. Like, why though? What happened to the fucking identity? Like, what? Oh, because it's called base whatever. Yeah, okay. Okay. So this part doesn't make sense. So we're going to say what is going on with this fucking code, dude? What the shit? Oh my God. It just, he doesn't, yeah. I mean, he just sort of dropped into this parser and like wasn't used to it and wrote it whatever made sense to him. But it's like way more like we're seeking ahead multiple tokens for a long time. Like it's kind of ass. It's completely unnecessary, right? Fuck. Like I'm torn between like totally refactoring this code and just adding the feature. I'm leaning toward just add the feature because that at least gets me more familiar with the code, right? But there's no, you just shouldn't. I see why he's doing it. I see the issue. I don't know. Let's just try and do the thing. Okay, so if size, that's a character, right? Or size ident. So in these cases, we're going to eat both of these. All right. So we still should get, unknown operand or whatever. Oh, make ident doesn't. Like that. Dude. Okay. So I don't even know if we want to do make ident really, or like put it in his identifier array. Okay. I guess we generated this instruction at size 0 or something, or there's a default. Like maybe there's a default if you say bswap. But the result is coming back 0, so we're definitely doing something we don't like. Let's just do this. just as a stopgap, right? And then it should work again, I guess. Yeah, it works. So, size identifier. The problem is, this is totally the wrong place to do. Okay, we're kind of fucked. And I knew this before, and then I forgot, right? Okay, the problem is he is doing mnemonic selection in the parser. And the reason that is bad is because you have no semantics available, right? So you're putting this in inside a procedure. That's the whole point, is you want to integrate. Now I know why he didn't want to do this when I was talking to him about it. Because you want to integrate with the function. That's the whole point. It's inline assembly, so it needs to understand the programming language it's in. And what that means is, you know, you just want to be able to read variables and stuff, right? And do stuff with them that are from either globals or the parameters of the function or whatever, right? Because that's what I'm trying to do for this feature. Now, the problem is you can't do that in the parser because you don't know the meaning of any of the variables, right? Because they've only been parsed. Like, they haven't had type checking or anything run on them. So this is totally the wrong time to do this. So this is the problem. We have to do surgery on this thing and get that to work. We have to move this to another stage of compilation. Maybe somehow that won't be that hard, but we're basically, when we parse like this, we're going to have to store the we're going to have to store the size and the base name, right? Which I guess we have base. No, because that's a token. God. Right. So we're going to have to make an actual identifier, which we should have done anyway. Or like, this code will get a little neater anyway, because it won't be so gnarly. But we're just going to have to put more stuff on this instruction struct. And then do the thing later. Now, the good news, though, is because I think the operands actually do we're going to have to change the parsing a little bit, because it's like it thinks it knows how many operands the instruction has, which we don't know yet. So yeah, this is a pain in the ass. And I wish I had gotten him to do it before he moved on. Oh, God, I hate... Dude, oh, I fucking hate this so much. We're going to have to move a lot of this stuff to later. We'll do it piece by piece. Oh, I hate this, dude. I hate this so much. I didn't even know there were rounding modes. So basically, we have to parse all these factors unconditionally and store them in the data structure and do the instruction resolution later. This is exactly the kind, like, I wish I could pay people to do this stuff, but like, I always end up having to do it. Like, this is my life. Like, why? This is something somebody 2 years out of college should be able to do. But I have to do it. Merry Christmas to me. Oh my God. All right. So our job now, unfortunately, is to completely transplant this and rip it up and have it still work at the end. And we're going to do that one piece at a time. And the problem is we can't, I wanted to resolve the mnemonic later, but we have to peel it back and do that last. Because all this code down here wants to know the mnemonic, right, in order to parse. Which is like, again, you don't do this. You just, if you know enough about programming languages, you do not do this. But this was done. So, fuck. All right. It's not in principle that hard, but I am not the author of this code, right? So I'm unfamiliar with it. So it's going to be much harder for me to do it than if someone, or let's just say more agonizing. It's going to be more agonizing. There's nothing here as rocket science, right? But it's probably easy to get something wrong or drop it on the floor. But so, okay, one thing we could do is look for operands. The other thing I notice is there is a comma in here being used already, right? Didn't we see that in like the number of operands? Yeah, so we shouldn't use comma actually. All right. What a butt pain. Okay, so we're going to comment this out for now anyway, because the objective is not even, the objective is to stop being sad for a little bit. So, all right. So, okay, let's look at, we're looking from the bottom up. So if we have a rounding mode, does this have to change? No. It looks like this is fine because it's not doing anything that depends on any context. Right? So to be clear, the thing that I meant when I said you don't do this if you know about programming languages, you don't make parsing heavily context dependent. Because a lot of reasons. Because it forces you to do everything in order, first of all. Which for, if you think, oh, we're just doing inline assembly, that part doesn't seem like a big deal. Like parsing in order, okay, fine. But again, it means you have to know what everything means. And so you can't have any, you know, again, any semantic interaction with the external programming language, except where you prepped for that. Okay, so let's look here. I'm really going to want that tea with peppermint. I hope it's not disgusting. Okay, so here, is this contextual at all? This is. But the rest is not. And since, okay, here's what we're going to do. Since we know that the rest of the inline assembly, or all the inline assembly in the system, since we know it's correct and runs to the best of our knowledge, I'm going to put delayed type check here. We don't need all the error reports right now if we don't go working on the code, right? So this part that does the actual parsing is fine. This, which is contextual. Oh, wait, num operands. Hold on. Is num operands... I'm not sure. Okay, does num operands... Okay, that's actually fine, actually. What was the thing about... Yeah, okay, that's also fine, because that's just parsing, right? But what was the contextual thing? Oh, no, I misunderstood. I thought this was an intrinsic property of the instruction. No, this is just how many operands have we appended. So actually, even though I was just dreading and making frowny faces and stuff, we might be in better condition than I thought. I don't like it when people passively aggressively change the other person's syntax, but if the other person's not working on the compiler anymore and I am being forced to do big things with this piece of code, then I get to passively aggressively change it to syntax that I like. Okay. Although I don't really know why I like this more than this. I mean, this is actually, that's a reasonable thing to do. But this is just how I do it right here. Even though this looks really crammed in this case. It looks less readable for sure here, but like that's just what I do, dude. Sue me. Okay. Nasty gram averted? No, there's not going to be a nasty gram either way. Like, this has been useful work in the compiler. People have gotten good mileage out of it. It's fine. It's just, I wish I hadn't gotten pushback when we talked about this a couple years ago or whenever it was, because I was right. Okay. Okay, so let's just look. We're going to do a sweep bottom up and look for what we actually think is... Maybe there's no context here and we're actually fine. Like, that would be awesome. Maybe I was just totally wrong when I was complaining about that a second ago. Because now that I understand what this is, I'm not seeing a lot of context. So maybe I lied when I said he did heavily context-dependent parsing. Maybe that was my personal hallucination, which would be awesome. Yeah, no, you know what? I think we're in much better shape than I thought. Okay, so what is this? If we get a number, memdisp, I don't like that. I don't like when I read variable names and I don't know what that means. How, and you can't like Google memdisp and expect to know what that means, right? So that's a problem, but we'll live with it for now. So we make this literal, and then we just put, I guess we just have an expression array. But why? Okay, hold on. So we have an expression array here, but we have operands here. Why is that different? Why is there an expression array that isn't operands? I guess that's for... Wait, this is going into a global thing. Okay, so this is the index of this literal. So mem scale, right. So this is for doing like the little operand. We're doing like, you know, times 8 or whatever, right? Down here. This is actually fine. No. I take back literally all the bad things that I said. This is a lot better than I thought. I was misinterpreting. Okay. We don't have to do a bunch of horrible, ugly stuff. Hopefully. At least it's not obvious. So let's just look at this instruction struct now. Because basically we want to put a different size on it. Where is it? Instruction. ASM x86 instruction for selection. Okay. Mem position modifier operands. U16. So these are all indices. Oh, it even said. Oh, this is a good comment. If there was no parse context and everything was just directly on the AST node. Yeah, I don't know why there's a parse context, but whatever. Okay, so these are indices into the ASM expers array, which is global, which is actually fine. That's actually what we want. So really what we want here, what do we do with that size number? Okay, here's the problem. The problem is we do have a little bit of a problem here, but it's not nearly as big as I thought. The problem is we are the main problem I see is actually this. And Ryan's not going to like this, but okay. This is why I got started on the wrong foot, because this part actually does need to change. It actually does need to go till later. So let's check who uses this later in the function. Nobody. Okay, that's good. That means we could potentially do a clean transplant here. All right. However, so this is all we have to transplant, which thank God, that's a lot less than I thought. Is there a rando in chat? What's going on? Displacement is like the offset. Okay, that makes sense. Who do we need to ban? Is it Brains Man that we need to ban? So Ryan tends to use OXFF at the size of the field to mean uninitialized or unset. That's just what he does. Please no. So I actually do have an auto formatter in Emacs. It's just I don't use it very much. And it doesn't have lining up stuff like this. You could use CCC. No, you don't want to use CCCC. Because CCCC is in a debug build in the Microsoft toolchain, at least. CCCC is how the stack gets cleared to help alert you by crashing to variables you're using that are on invalid regions of the stack. So you don't want to use CCCC. You don't want to use DDDD. You don't want to use CD, 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 etc. Because those all have meaning for you. Okay, I'm going to boil some tea water. I'll be back in a second. And what we're going to do when I get back is we're going to make an identifier for this. And we're going to stash it. And then in type checking for ASM, which right now is probably a no-op, maybe not, actually. Actually, it probably iterates over all the expressions, maybe. Or maybe he does that in the back end. I don't know. We might have to move that also. But the point being, we will add a pass that zips through and sets instruction.mnemonic based on the stashed identifier and the size parameter, which is not currently being stored. So we need to make a field for the identifier. We need to make a field for size ident, and we need to make a field for actual integer size. And then we'll see. If I did want to try Clang Tidy, no. No, I don't want to use Clang Tidy. What are you talking about? No. Like, I have my indentation style that I like. Here, okay, here's the thing. I've given this rant before, but because people have been talking about it for a year, auto formatters are not actually good, right? Because when you program a lot, you're at home. Like, you're building your home and you're living in this room as you think about the problem and you work on the problem. You want your room to feel good to you. Okay? You don't want to have to live in like a generic IKEA showroom room that you're not allowed to modify or like move the couch or change the color of the walls or anything like that. And this auto formatter trend says you're not an individual, right? You have no individual expressivity at the level of style. And I don't like that at all. I don't like that at all. You are free to disagree with me about what good indentation is, and that's fine. And in your code, use what you like, and in my code, I'll use what I like, right? But this whole like Clang Tidy is very configurable. So is Emacs. Emacs has an auto indenter. I just don't bother to configure it. I use it sometimes. I don't bother to change the settings because I'm a productive programmer. And productive programmers don't spend all day fucking with 10 million settings on everything. Okay. I'm going to boil some water. I'll be back in a minute. Water is boiling. So where is this instruction for selection? All right, so this gets filled out way after parsing. No check in, explain when done. We're going to have you know, he's sort of doing this very array-based thing. I don't care about that right now. I want this to work and be good and be easy to work with, so I'm not going to continue this. I'm just going to put the identifier, right? And if we want to make it an array thing, it doesn't really like, it's weird. It doesn't even save memory or anything because it actually takes more memory because you have the pointer to the expression in another array. So like what, I mean, I guess this lets you make it not a dynamic array. I don't know. It just, yeah, whatever. It's fine. So we're going to go S8 explicit size. All right. And we're going to have we're going to do these. No check-in. Oh, dude, none of this is going to work, in fact, until... Because it's in a macro, we have to copy the whole thing. Okay. Does the parse context... What is going on? Parse context. So he just assigns this lowercase c means just copy the whole parse context. Load info, feature lead. Why is that there? This is already on the base. So, yeah. Okay. Actually, we don't need to copy these things. Oh, we do. Fuck. Fuck. Okay. This is... Yeah, this is not good. All right. Let me get the tea. I'll be back. Okay, here I am swearing a lot, but maybe it's fine, actually. Maybe it's fine. And the reason why maybe it's fine, because what I'm thinking here is, oh, I was going to put on here, on the operand for, the instruction for selection, I was going to put on there more stuff that is derived properties. And the thing is, maybe it's fine. The only real derived property is this. and it'll just get, if it's already set, we'll copy it, but we don't care, hopefully. So maybe it is fine. However, the one thing that I'm thinking is size ident here actually should probably go in that expressions array and be an index. And I have to use Ryan's OXFFFF thing, which I don't like, but the point being, the reason I want to do this is because I'm assuming this expressions array like gets evaluated, like constant evaluated and stuff. And we want that for this also. So we don't want to make new special case code. Maybe it doesn't though. I don't know. Okay. Before we commit to that, where is that? Expers. Oh, that's okay. That's also an abbreviation I would never do. Inline parse context here and ditch the expers array. Store ask directly on instructions. I mean, maybe. Okay, well, if he was thinking that, there's probably something motivating that thought. So we're going to go back to this. Okay. So instead of setting the mnemonic, we're going to set the mnemonic ident here. And that'll let us simplify this code. Clean up so we don't peek ahead so far. We're going to go instruction.mnemonic ident is make ident this, comma, there. Boom. All right. Although even that, I mean, don't we just want to do that? Yeah. So this gives you the right source code location, whereas this takes the current. Oh, I guess the current, because you haven't popped the tokens. That might be another reason, because he didn't get. He saw that the positions were wrong, and he was like, okay, I'll pop the tokens later. But no, if you pass the token here, you get the right position. All right. So now we just won't be able to run because, you know, we can't do this. So maybe we put it there. I didn't realize this was in bytecode builder. Oh, I guess it has to be. Okay, do we use the mnemonic? So okay, so instruction for encoding just copies it. So we have to just move this code here. All right. And I hate these abbreviations, but it's how it is. Inst for enc. Oh, whoops. Okay, and then I don't know, if we don't find an instruction, I guess we'll return -1 here. But it's not a parse error. It is a different error. what did I call it? Mnemonic ident. Okay. Where is the peppermint honey? I left it in the other room. Let me get my peppermint honey and we will continue. Here we go. Peppermints. Do we think the tea is steeped the correct amount? You can't drink honey with boiling water. Honey produces a substance called dioxymethyl. Well, this water is certainly not boiling. Hope I don't die. I'm going to have to read about this, though. Dioxymethyl honey. I don't see any matches for this being a poison, actually. So, maybe that was an LLM hallucination. Have I read about the shungite? I don't even know what that word means. I hope it's not dirty. Whoa! Okay. It's interesting, the peppermint honey. I'm not sure I like it in tea. I'm not sure I like it in tea. Okay, I will click the Wikipedia article for later. We will not distract ourselves. I am having a great time lately because I think I hit on the right combo of supplements to like replenish whatever the hell is wrong with me. So I have more energy late at night. People who have been following the stream for a while know that I've been getting tired. And I'm also just losing weight naturally every day. I mean, we're only like 9 or 10 pounds down right now, but it's a pretty good start. So we'll see how that goes. We'll see if I need some shungite. But no, things are good. What's my diet like? I mean, it's whatever now. Like, I've gone through times of trying to have a strict diet and it never seemed to help. My diet right now, when I'm losing weight consistently, is just like whatever I feel like eating. Like, I've had a bunch of honey today. In this morning stream, I was eating honey out of the jar. What supplements? It would be hard to list because 2 of them are like multivitamins that have a ton of stuff. But aside from that, so I was diagnosed as hypothyroid like a long time ago, like 25 years ago. And one of the recent changes is I stopped taking levothyroxine for that. because I've never felt like it's a quite the right solution, but it's the best thing I knew. And I'm actually taking like desiccated thyroid plus some thyroid, you know, thyroid factors multivitamin, which is like enzymes that your thyroid wants or whatever. That's one change that I made recently. Another one is I added extra molybdenum. There's some molybdenum in one of the multivitamins, but I added some extra. Um, and I actually reduced the amount of the crazy multivitamins to a smaller level. So I don't know. Something about that. It's all working for me right now. Seems like I'm doing better than that. Yeah, I mean, I never had full thyroid failure, right? Like I've been for many years on the same dosage, which is 75 micrograms per day of levothyroxine, which is like if your thyroid didn't work at all, you would take way more than that, right? Um, but you know, it resulted in stuff. So people know what I look like from the streams, right? Like starting, I want to say 4 or 5 years ago, I just started looking tired all the time. And maybe part of that is getting older because I turn 20 next year, right? But part of it is just like I look tired all the time. And it's like, why? And it's what I sleep enough, I think. And it's like, I think it's the levothyroxine. I think it's failing to supplement some thyroid activity while burning me out on other thyroid activity. You know what I mean? And so it just feels more balanced now, maybe. Um, so I've been taking omega 3s. Yeah, I mean, if I were to add something to my current mix, I would put omega 3s in. There's probably some in the multivitamins, but you know, if you eat tons of seed oils, you can at least try to partially fight that by ingesting a lot of omega 3. Um, but it, like, to really offset it, it would need to be tons and tons of omega 3, right? So I don't know, man. Okay. So the size, we're literally just delaying this for now. We're not trying to do the new functionality yet. So explicit size. Okay. Okay. Inst for ink. Oh. Wait, what? Oh, it's not for ink. It's inst for select. Goofy me. And it's not dot. It's arrow because we're using a picky programming language. All right. Base ident. What is base ident? Oh, yeah. Inst for select arrow mnemonic ident. That might need a cast or something. Oh God, parse context. All right, where is that? Why is that a pointer? Oh, it's just literally copying over the pointer and not the whole thing. Okay, I misunderstood what was happening in copier. That's weird because I never do this in my own AST nodes. So yeah, it's a thing. All right. New string. Oh man. But that's fine. That's actually good. So we just don't wait. Oh, we don't have a new string. Oh, that sucks. New string pointing at C string. All right, we could maybe clean that later. I don't know. Oh, come on. Is it pointing to? I always get this wrong, dude. Like every time I call that function, I pick the wrong one. All right. Invalid instruction mnemonic. Okay. When is that happening? In bytecode builder. Okay. Oh, we never set the size, guys. That size field is totally not set by us. So we got to look back at the parser code and like, what would it be? What does he set size to by default? 0. Okay. So we actually, if we just want to get past that int 3, we'll go 0. Okay. Now, we just don't set it when it's not 0. So instruction dot, what was it again? Explicit size equals, it's a character, right? That's kind of weird. We could change all that later. And then let's, well, no, we'll move the identifiers later once things work. Okay. Still invalid instruction operand. Why? Why? Wait, that was a comma. Oh, when I changed it back and I was like, oh, let's just get it working, I put a comma W instead of a dot W. So that's, hey, look, everybody, it works. So our next goal is just going to be to clean this up and check it in. And even that will be a victory. But I kind of is anyone on the stream right now who's in the beta and uses inline assembly? I want to get an opinion poll of the 0, 1, or 2 people for who that's true. Anyone? Anyone? I'm a lot more comfortable eating butter than engine lubricant. I agree with that statement 100%. Haven't used it. Check Twitter. Hoping the code isn't too hard to change. I had a moment in the beginning when I thought it was, and I was freaking out, but then I realized I was wrong. So it's actually fine. The main thing that I'm just doing, let me describe to you what I'm doing, and then you can let me know if it's a good idea. There's going to be 2 things. One, you had this note here about, There's a weirdness where the dot will get pulled into a floating point number. So the simpler thing is just going to be, I'm going to add a contextual mode to the Lexer that lets you do this. And then because we're theoretically at least kind of trying to be cross-platform, then I think we'll probably at some point change the defaults to be like 1, 2, 4, 8 instead. Like we'll still parse these, but I think when we print out the instructions, it's probably better to use the numeric size than these. I don't know, maybe not. That's one thing I wanted to poll people who use this on, right? But we would also just parse 1, 2, 4, 8 here. That's the easy one. We haven't been doing that. What we've been doing is, you know, I want to be able to basically do the following thing. And I don't know what the syntax is going to be, but we have to make up some character. And then like this, where the size comes from a variable, right? I think well, it doesn't help there actually. But like for these two, these are the same code, but for the size, right? So you could collapse them. And all over the code, whenever there's a polymorphic variable, we have this pattern. This one is actually the most heterogeneous, but a lot of the time it's like literally a straight up pattern where you do all four. And I assume when we go do ARM, it's going to be even more that way because ARM is less historically screwed up. Maybe not. I don't know. So I wanted to put that in, and what that requires, of course, is you need to know the meaning of size or t when you select the instruction, which you don't know at parse time. So I've basically just been delaying the instruction selection to, you know, in bytecode builder here. And the reason I was freaking out was because I incorrectly thought that a lot of the later parsing depended on the specific instruction, but that's not true. That was just me misreading the code. So I think we're fine, mostly. You want to say that we infer the size based on the high-level language type. Oh, really? Really? Are you saying that if I do the following thing, I can just do this? No. Yeah. So this is like size 0. Oh, well, I mean, maybe I just broke it, but I don't think so. I think this never worked. Actually, we can tell because the release compiler has not been messed with. So if I do this, yeah, it doesn't work. We could do that. I thought about that. I thought about like, should we automatically infer? But I think that's maybe not the right thing to do generally because like you're going to want to write into the bottom. If you're doing SIMD stuff or whatever, it's like, look, I've got a big data type and I want to read from the first half or something. I don't know. Maybe that's true. I don't do enough SIMD stuff these days to know for sure. Maybe it doesn't work right in the macro. Oh, you mean like in terms of getting copied or something? Yeah, I mean, we could simplify this code. Instead of putting it in a macro, I don't think so. I don't think the macro is a problem, but we'll see. So we're just going to inline this down here, there. And instead of input, it's value. All right, this is a bigger mess, but its address gets taken. Oh, because we print it. There we go. Yeah, it still doesn't do it. So I don't know if it's supposed to do it. It doesn't currently. But I don't think it ever did. Unless it does in some specific case. Like, we literally don't have any assembly code in the system that doesn't have a size suffix, I don't think. For scalars, you thought you had it working where it picked the size based on the int type. If you did that, I don't think I ever knew that that was how it worked. And then again, if we... I mean, we could just go look at some random assembly code, but I'm pretty sure... Like, I'm pretty sure we would have used it if we had it, because this thing always annoyed me. And, like, if we go somewhere that has these... Yeah, like, it always... You know, these were some of our original, like, code where we're testing assembly. And it's just always had explicit size suffixes on everything. And so we could... I don't know how much work it would be to infer it, but I also... I don't know if that's the right thing. Oh, I didn't save this out, but this was me, like, demoing, like, maybe you put an @ sign and then the type or whatever. Yeah, no, like, literally everything is suffixed all the time. Pop count's a good example, right? So there is no 8-bit pop count on x86, right? Because they were like, we don't want to do that. I don't know. Maybe there was a collision with something else, right? So you literally have to do a 16-bit pop count if you have an 8-bit value. And so you can't literally collapse all of these, but it could be 2 cases instead of 4, right? Yeah. What about Apollo time? Let's see. ASM. Well, yeah, so these moves don't have suffixes. So what's the difference? Why does one work and the other doesn't? That's literally the only assembly in the whole file. But like, this was probably copied and simplified out of int 128. Yeah, these also, huh? Oh, but maybe it just defaults GPR instructions to .q. Maybe. Okay, if that's true, then if I let this, so here we're going 1, 2, 4, 8, right? And I'm asserting. If that's true, 8 would probably work. And we just can't see that because I'm asserting, right? So let's not assert on 4 and see what happens. And let's do it with the release compiler that doesn't have my new screwy stuff in it. Okay, yeah. So I think you're defaulting to 8. That makes sense. I mean, that would be another thing of what to, like... I mean, I guess if you're moving from memory or something, right? you don't know what the size is supposed to be. So I think in a lot of cases, if we were to say, no, the policy is not to default to 8, it's to default to whatever, I think in a lot of cases, we wouldn't know what the size is supposed to be. So I feel like maybe, um, yeah, this is funny. I thought it was result 0 because we were like doing something bad. It's result 0 because we're byte swapping with something that has 0 in the upper bits. Um, like, I think it makes sense to maybe leave it this way and then add this specification mechanism on. Let's see if my screwy changes still work here. They're not screwy. They're me learning. I'm learning. Yeah. Anyway, if you read that tweet, there's been a little bit of discussion after the tweet, and like, I wasn't sure when I wrote it whether we need to do inline assembly at all or whether we should externalize it or do intrinsics or whatever. I think the vote seems to be in the near term to sort of leave it the way it is and just expand and do ARM and all this stuff, right? And then maybe, so the idea that maybe also turn the tables is like, if we do want to add flexibility for external assembly, and I don't want to worry about the complexity of maintaining tables and stuff, we could compile the user level tables back into C++ and like sync them that way. And that's 20,000 lines of, that's the majority of the thing to maintain, right? So it's maybe not as scary. Like, at some point we would just need more people to do all this. But I think for now, we're staying the course with the way inline assembly happens. But we might have to do intrinsics also. I don't know. Maybe not. It depends, like, because I don't know how much of this you remember, but like, we were having all these issues where it always had to be in macros because the type system didn't really understand, like, passing a SIMD register around as a parameter or something, right? So you couldn't use regular inlines. So we did that there's just these weird, messy, and we still have a lot of junk instructions. I know you cleaned up a lot of them, but like, there's still too many to have like one macro call per intrinsic right now, right? So we kind of can't quite do intrinsics at user level. Maybe we could. So when we go to implement intrinsics, maybe it's an extension of this, and we just do a better job of being able to glue them together. And that includes more knowledge about the types that are flying around at the compiler level. Or maybe they're just a separate thing. I don't know. I haven't figured that out. But we have enough positive feedback on people who do use the inline assembly that they like it. And I'm like, all right, we'll keep it. And so that's the other thing that I was saying at the start of this stream too, is like, if we're trying to compare inline assembly versus, the idea of what intrinsics would be, that's already kind of a flawed comparison because it's between one thing that exists and another thing that doesn't exist yet. So you haven't seen the problems in the other thing. But also, if you're not doing some of the low-hanging fruit that would make the inline assembly better, then it's not a good comparison either, right? Because you're comparing something that could be a little bit better easily versus another thing. And so I certainly wanted to do, but I feel like at least for the next year or two, this is just the decision. It's like, we're just sticking with the inline assembly. Your semi-baked take is that this complexity of multiple instruction sets just exists whether we like it or not. Yeah, I mean, that's okay. Back when we were, when you were on this project, right? And we were talking about it regularly, I sort of came to this conclusion that like, basically intrinsics and inline assembly are the same thing, right? And you sort of have the same problems either way. But, and maybe that's still true, and I just haven't thought about it in a while. It's just, I don't know. Like, I felt discouraged by how much work that I would do to like make this work really smooth without any junk instructions and all that. But I mean, I think again, maybe that's the same work you have to do for intrinsics, right? It's like, look, the compiler has to know about what the data types are that you want to manipulate. And what, so we would add more to, right? So you have this like type def reg right now that you use for that. And I think we would just have to get more explicit, right? Like this is float 32 times 8 or whatever. And then maybe we have to add float 16 times 16 and all these things. I kind of don't want to do all that, but maybe it's just unavoidable, right? I mean, I don't know. Didn't Zig do all that? Like, don't they have like SIMD built in as like a higher level thing? Not really. Which one? Odin does. So how do you like that? How do you like the way that Odin? I don't know how Odin does intrinsics, but how do you like whatever they did? Why float 32 times 8 instead of F32 8? What's the difference? That is a good question. The difference is the following. Maybe nothing if I am smart and figure it out. But right now, we have a convention in the programming language that any array or any struct is treated as what's called a large value, even if it's small and would fit into a register, right? It's treated as a large value, which means it's passed around by reference and all that, right? Which inherently is incompatible with this idea that you want to load all the floats into a register and do stuff on them, right? Maybe in reality, that's not a real conflict. But again, it would sort of imply that it wouldn't be able to live in a register if you passed it as an argument, or you would at least have to write it out. Because I don't know, like maybe you can, but then you start making the calling convention really complicated. Like, oh, my calling convention has like vector awareness in it and stuff, right? For arrays automatically, right? Why does an F32 sub 7 act differently from an F32 sub 8 if it does, right? So all these are just complicated questions that I just, this compiler is really complicated. It's really complicated. Oh my God. So like, I don't want to keep going down that road of complicating it more, but maybe that's what we got to do eventually. I don't know. Whereas if you say F32 times 8, then it's like, oh, this is a thing that the compiler... Okay, well, and this is another... Aesthetically, we lean in the direction of... like not relying on compiler magic, right? So if you say there's an array of 8 of float 32, and that the compiler treats that specially, but a different length array of a different type isn't treated specially, you're kind of relying on compiler optimizer magic to do a good job. And the problem is programmers who sit down and do intrinsics or inline assembly do not want to be relying on compiler optimizer magic to make their program good. They're saying how to make the program good. That's why they're using these systems, right? So you just don't, like, if you're building semantics that rely on compiler magic, you're inherently doing what this audience does not want. All right. So if you make just a specific type for it, right? Like this is a vectorized float 32. You expect that this targets, you know, SIMD or whatever. On the one hand, that's more complicated in some way, but on the other hand, it's very explicit and you're giving people what they want. Oh, hey. Yeah, you're welcome. You look tired today when we rated you. Where do you live in the Western Hemisphere, or are you like in the Eastern Hemisphere somewhere? Like, why are you awake at 8 p.m.? F-32 times 8 also gets to have its own alignment. Yeah, like there's all sorts of things like that. And it's just, I'm just worried about the amount of added complexity that this would entail. And I've been trying to avoid it, right? Felt like European. Well, then he's up at 4 in the morning. You're in Asia. Oh, so is it morning for you now? Have you gone to bed since that stream and you woke up? Know your schedule. Okay, you're on programmer time. I get it. Wait, where in Asia are you? Are you like somewhere awesome like Singapore? Where are you at? I'm trying to dox you. Asia is a modest way to say Russia. I mean, it is Asia. Novosibirsk. I don't remember. Let's learn. I know where Moscow is. I've been there. I know where Petersburg is. I don't know where Novosibirsk is. That like near Petersburg? I'm learning. I'm learning. All right, it gave it to me in Cyrillic. That's great. I don't know how to read the. Oh, it's over. Wait, it's over there? I got it totally wrong. Okay. Wow, you can go visit Borat. He's a mere 5-hour drive away. All right. Yeah, I've literally only been to Moscow, and that's just only for a few days. Wow. Yeah, that's Asia. Like that is literally Asia. Is it mountainy there? It looks pretty mountainy. See all the mountains on the map? I kind of wanted to go back to Russia again, and then like, the Biden administration happened. Um, so I probably could not get a visa there now unless it was a very special situation. But maybe we'll fix that. Change the satellite imagery. Is Russia still sanctioned? I mean, I'm sure. I'm sure, right? Oh, it's not that mountainy. Oh, it's just green. These are the mountainies over here. Oh, it's mildly mountainy. Glory Monument. Let's see the Glory Monument. Yeah, okay, that's pretty heavy, dude. That's pretty heavy. The thing is, I mean, the Nazis only kind of made it out this far, right? Or something. I forget. Wait, where was Stalingrad? Where was that? It got renamed, right? Where was that? Yeah. Okay. So they didn't make it that far. So I guess this is just like I mean, probably everybody sent soldiers though, right? So that's probably makes sense. Did they not make it to Moscow? I thought they were marching on Stalingrad and didn't make it all the way because it was winter and they were dying off, right? Or was it Moscow? I don't know. Dude, I don't know. Didn't watch enough History Channel, okay? You know how History Channel has World War II documentaries 24 hours a day? There's the famous map, right? Like, what was the map of, I don't know, whatever this was. There's this famous visualization of like how, like the line thickness is like how many troops are still alive. And it's just brutal. For some reason, this search is not giving us that. I think it's in the what's his name book about how to visualize things. Napoleon map. No, there's a Russia one or a Nazi one. Napoleon? Are you kidding? Napoleon troop strength visualization. No, this is not the one that I was thinking of. There is one like this for World War II. Tufty, yeah. Dude, yeah, we're not getting a lot of programming work done. Okay, this thing. Oh, it is Napoleon. Dude. Okay. I remembered it wrong. No, I've seen one. I've seen one for Hitler as well. I mean, Hitler didn't go himself, but I've seen one. And I guess I'm conflating them because I've seen that visualization for both. I don't know. We should program. We shouldn't keep going on this. But yeah. No, I definitely remember this one now. So this is the one that's in that book, the Tufty visualization book. But there is also a World War II one somewhere. But it's pretty brutal, dude. Like, this is who goes out and this is who came back. But, like, on the way there, like, look who even made it. Ugh. Ugh. Sorry for derailing. No, this is educational, right? This is educational. I've been to Moscow for a few days. I've been to Georgia, mostly just right here where all the markers are. And that's about it in that area. I've been to Prague a few times. I've been to the airport in like Warsaw or somewhere on a connecting flight. And then I've been to Croatia a couple times, or just once, which is pretty far from all this stuff now. So, yeah. This part of the world I just haven't spent much time in. Even like China, I've been to Beijing and that's it. Oh, and like Hong Kong, which was not being run by China when I went there. Like I haven't been to all this, dude. I've been to a bunch of Thailand though. Never been to India. I have a ticket to a thing in India, but I may not go. Probably won't go. I just don't want to travel that far next month. So, yeah. Dude, look at that terrain. Look at that Pakistan terrain, dude. That's some Younger Dryas flood residue if I ever saw any. All right. Come to Poland. You know, I want to go to Poland. I think Poland would be really cool. And I just have not made the time. Maybe I could this year, like sometime when the weather gets nice. I've never been there. I've never been like up here. Like I wouldn't mind going to Estonia or like Latvia. Lithuania, I don't know. Yeah, who wants to go to Lithuania, man? That's a joke. I don't really know. I've been up here, but I've been to Denmark several times. I've been to Sweden a couple times. I've been to Uppsala here. There's like a pretty famous restaurant here at the university. Where was it? Where did I stay? I stayed somewhere. It was not downtown. And there was like a famous, like a 3-star Michelin restaurant or something, just run by this dude who's totally down to earth. And it's the hotel restaurant of the hotel that's like on the university campus or something. Weirdly. Or next to it. I don't know. And I didn't know that, so I didn't reserve a spot at dinner. Should check out Chengdu in China for the best spicy food you'll ever have. I am not motivated by spice levels. Let's put it that way. Why can't I find this? Where was it? Let me see. I guess there's a bunch. Maybe I can remember where it was. This agree and close. What? Oh, wow. Dude. Wait, really? There's this many? No. Well, there's one at the golf course. All right, we're getting pretty derailed here, but the Cock and Bar. This isn't things that actually have Michelin stars. This is just, well, I don't know. This is just the website. Was it there? I don't know. They're Michelin tire shops. What about Latin America? I mean, I've been to Latin America a couple times, and I've just never had a good time there. I've been to Brazil twice, at least. I've been to Buenos Aires once. I just haven't had a good time. All right. Let's go back. Have I been to Iceland? No. No, I have not. How many countries have I been to? I counted once a long time ago. It's like a lot. Okay, let's continue to derail for a minute. I'm going to look at the map and tell you all the countries that I've been to. Okay. USA, yes. Canada, yes, but only on the east side here. I've been to like, Montreal, basically. But that counts. Mexico, yes, but only literally to Tijuana. But that's over the border, so it counts. I used to live in San Diego, right? So I've been here. That's literally it for Mexico, but it counts. So that's 3. Somebody make sure we don't lose count. No Central America. I've been to Brazil and Argentina. That's all in South America. So that's 5. Let's go over here to Africa. I've been to South Africa, Botswana, Zimbabwe, and Zambia. Is that 9? Are we at 9 now? Um, and then probably nothing else in Africa. Okay. I've been to Portugal, Spain, France, Switzerland, Germany several times, Netherlands, Czech Republic, Austria, Croatia. I don't know how many more that is. 16? Okay, I'll take your word for it. We're not going to count Poland because I was just in the airport. Um, Georgia, I've been to. Russia, I've been to. Denmark. Oh, England. Sweden. Okay. That might be. Did I miss anything over here? Let's zoom. There's a lot of countries here. I've never been to a lot of the more famous places you would want to go. Oh, did I say Portugal? I think I did. I think we counted Portugal. Okay. Literally nowhere in the Middle East. I mean, unless you count Georgia as Middle East, it's kind of borderline. Like, actually, Turkey is kind of borderline Middle East, and Georgia is like, yeah, not really Middle Eastern at all. It's got mild influence, let's put it that way. Um, okay, we're going over here. I've been to Thailand. I've been to Myanmar with a walking visa over the border from Thailand. Here, we went from Chiang Rai to Tachi Lek. So I've been literally walking around here and then back out and checking out all the dudes with AK-47s on every street corner. But that counts. So that's two more. I've been to Cambodia, to Siem Reap and Angkor Wat. I've been to Singapore. Where are we at? Where's Singapore? Am I being stupid? There it is. I've been here, but not to Malaysia. Okay. I've been to... Okay, well, here's where it gets controversial. I've been to Taiwan, and I've been to mainland China, and I've been to Hong Kong. So how do you want to count that? How many countries is that? I've been to South Korea. I've been to Japan. I've been to Australia. We might be running out of places. I feel like I'm missing some things, but oh, did we count Czech Republic this time? I know I mentioned it before. I don't know if we counted it when we went through all this, but yeah, I've been to Czech Republic. Yeah, that's approximately it. However many countries, whatever that goes up to, is about it. I got to go to South Sudan. Why? All those travels, is there a dish that stands out above others? I mean, Thai food is really good, dude. It's hard to beat authentic Thai food, I think. But that's like my personal taste, right? How many US states have I been to? All right, so 33 was the count. I feel like I've been to more than 33. But it's easy. Like the world has a lot of countries in it. It's easy to miss. Okay. US states. Isn't this a great programming stream? Okay. I have been to. I was born in California. 1. Oregon, been to. Washington, been to. Nevada, been to many times. Utah. Arizona. New Mexico. Colorado. Is that 8 now? 1, 2, 3, 4, 5, 6, 7, 8. I haven't been to these. I don't think. Nebraska. Texas. Louisiana. Mississippi. Missouri. And then I think I've been to Minnesota. Like, I can't even tell you for sure. Because I don't remember where this thing was, but it might have been Minnesota. It was one of these states up here. Tennessee, North Carolina, South Carolina, Georgia, Florida, Virginia, Maryland, New Jersey, New York. Have I ever been to Pennsylvania? I don't think so. Connecticut, but only like driving from the airport, but that counts. Massachusetts. We already said New York. I've been to Vermont. I feel like we just missed some states and skipped over them, but I've been to all of those. That's the minimum count of how many states. I mentioned Florida and Georgia. Only 26? Sad. Did I say Louisiana? I must have, right? Like, how are there that many? Oh, Hawaii? We didn't say Hawaii. Hawaii +1. No Alaska, though. Oh, does DC count? No, because it's not a state, but I've been there. Yeah, there's sort of this area up here where I haven't really been. Like, I haven't been Idaho, Montana, Wyoming, North Dakota, South Dakota, or Wisconsin, or Iowa. Like, this is a whole chunk. Where do I live now? Colorado. See where all these things are? Don't dox me. That's where I live now. Do I like road tripping or flying? I mean, I usually fly places because road trips just take a long time. And if I fly, I can like program while I'm flying. I did road trip from San Francisco to Austin, but that was a really long time ago. Okay. Hey, why don't we program? You got really surprised when you learned there's a city of St. Petersburg in Florida, and it's not a coincidence. Did you learn that from me? I lived in St. Petersburg, Florida for a year. Let's bring that. We're distracted today. I liked living there. It's a little small. It's not like St. Petersburg, Russia, but like it's fun. You got a bay on one side and a beach over here, and just it was very like I lived like I'll show you where I lived. Literally right here. This was my building. It's like a 18-story building, Camden Pier District, and I would sort of go out and go down here, and there's just a bunch of just coffee shops and stuff to chill and do whatever, and I had fun there. And the downtown is like pretty there's a bunch of people with money at this side of St. Petersburg, and then there's a bunch of beach bums at this side. Right? So as you go east to west, it's a spectrum. Yeah, I lived there not that long ago, from 2022 to the beginning of 2023. And then I moved here, and I've been here for almost 2 years. I was kind of in both places back and forth for 6 months. But yeah, this last hurricane that hit Florida went like right over St. Pete's and Tampa, is what I heard. So yeah. I've also been told, I didn't know this, but Clearwater is apparently the home of Scientology, and that's right next to St. Pete's. Let's find this. Scientology. Oh boy. Look at all the Scientology, dude. Also Christian Science, but the Christian Science here in town, you walk by and they have a sign in the window that says, "We have nothing to do with Scientology." So, yeah. Okay. Did I move to Colorado because of the weed? No. Weed will ruin your life. Don't do it. Don't do it. Why? Because it just puts your brain into a low gear, basically. All right, we're going to continue the feature. We have spent like an hour doing fun map stuff, and now we're going to do the feature. And so we have to set the size ident in the parser. But we don't want to use comma. For right now, I'm just going to use a random character. Actually, no. Now that, okay, first of all, we need to put this back so that this works. We just want to be in a working condition. Right? And then we can do stuff from the working condition. All right, so this is bswap.w again. That's so confusing. All right. So, wait, what? A matching instruction. Oh, wait. Oh, it's D. We got to put the numbers in there, dude. All right. So we're in working condition. Let's make sure everything's in working condition. We could have done this while we were looking at the maps. That would have been helpful. Thoughts on preemptive multi-threading. This is why thoughts on is a banned phrase, guys. Like, what do you mean thoughts on preemptive multi-threading? Like, you typed that via preemptive multi-threading on a system. And I read it via preemptive multi-threading on a system. Like, what do you even mean? So I'm seeing a bunch of thoughts on come in now, of course. Don't I think cooperative is better for performance? The answer is it doesn't matter now because all systems are multi-core now. So like most of the time if you have something active, it's going to have its own core, at least, probably several. So like it's an old model to assume that there's one core and everybody's sharing it. And in fact, it's only because software is so slow and has so much inertia and suckiness that we have not transited to like a regime where all operating systems just take one core and live on it for security reasons. Like that's clearly the right answer now because all these like frickin', timing hacks and stuff are taking advantage of the fact that there's a very small but exploitable information leak when you share a core with the operating system. The answer is just to move the operating system to its own core, right? But we don't do that because everybody's afraid of being able to change their software. Like programmers used to be much bigger than computers, and programmers used to tell computers what to do. Now programmers are much smaller than computers, and computers tell them not to expect much. And it's very sad. So, thoughts on my wife's boyfriend. All right. All right. But yeah, you don't like that's a very old the model used behind that argument of cooperative versus preemptive is very old. And like the fact is, cooperative doesn't work if a program can infinite loop, which all programs can do. And so what, right? Much like how game developers used to be bigger than the games. Yeah, I mean, it's happened everywhere. That's why. So that one of the reasons I'm making a programming language is to push back on that trend, even just by 10%. If we can reverse that trend by 10%, then we're still in a bad place, but we can get further. Because like we're being stopped, right? Like the entire software industry is being stopped by this, complexity bound, by this inertia. So yeah, it's not great. You're going to infinite loop either way. I mean, no. If a program infinite loops in a cooperative multi-threading system, you're done. Like you can't run anything else, right? In a preemptive system, it's eating CPU, but you can at least preempt it and go do something else and then kill it. All right. That's why preemptive won. That's the main reason. And also just responsiveness, right? Like in cooperative, you have to call the yield function pretty often. And I mean, have you ever seen frickin' Discord or Visual Studio Code startup? Like, they ain't calling yield in the middle of startup for 30 seconds. You don't think it's complexity, it's a lack of philosophy? Well, part of that lack of philosophy is how to manage complexity because people just seem to love adding needless complexity. All right. Anyway, we finished. That's great. So, I'm just going to juggle stuff slightly. So we're going to eat this token right here now, and we're going to be very conservative again because this isn't my system. So I don't know how it works, but okay. So we can do that. And then now, like I said, we don't need to peek ahead so far. So we can move this up here. At least. And then this is a peek ahead by 1. So we've shrunk the peek ahead size, which is good. And we can eat these. So the reason we couldn't eat these, let's just put this here for now. But the reason we couldn't eat those is because we didn't want the identifier token to get overwritten. But now that we're making the identifier earlier, then we're kind of Gucci. So, all right, so that seems to be going. So now we can just put these here, right? We can eat the dot right there and peek the token and eat the token. This is how I would write. Like when I'm writing a parser, I don't want to be writing ahead, thinking like peeking ahead very far, because it makes you think harder when you're trying to understand the code. You're like, where's the token cursor and where are the things? And it's like, no. Let's not do that. All right, so now peek next token. So actually, yeah, before we try to do the new feature, like I said, I just want to clean this, clean this up and check it in. And then that's our foundation to expand from. Okay. Okay, this doesn't need to be here anymore. This doesn't need to be there anymore. We probably have some no check-ins that say comment and explain things. Okay. So it is violating the convention of everything else here that it gets set during parsing and then is unchanged. But Ryan had notes about folding this into the main struct anyway, so let's not worry about it. Okay, so we've explained that. What else do we need to explain? Comment about mnemonic being set late. Oh, okay, that was... that is the comment that we did. So I think we can check in. Unless I accidentally messed up a file in modules and saved a no check-in, but I don't think I did. All right, so let's take that W. I was freaking out in the beginning, but I was wrong. We're fine. Sorry, Ryan, for freaking out. Refactor ASM so that mnemonics get chosen in bytecode builder so that we have resolution of various symbols. Okay. So I'm going to check that in. Now, we get to do a new thing now. Given a number n, generate all strings of length n containing open and closing parentheses that match correctly. Like only parentheses? Or can there be other things in there? Because that's actually, if it's only parentheses, it's actually an easy problem. if you think about it. Only parentheses, yeah. Right? So obviously, okay, wait. So it's only exactly length n, not things that fit into length n, right? So if n is odd, then the answer is there's nothing, right? And then for n even, you basically do a tree search, right? You basically do a depth first search on a tree or breadth. It doesn't matter. But there's a, you basically have to have an equal number of downs and ups. You have to end at the root. And so the first one is left, 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 right, 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 and then left, 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 all of that minus one, and then a right. And then you just reverse that sequence for however many, and etc. Right? So you're essentially navigating a binary tree, but you don't need to create a binary tree. You just could think about it that way to make sure that you're doing everything. So it's kind of a cool little programming test problem, right? It was also a whiteboard problem, and they wanted valid syntax. Oh, like they wanted you to write it on the whiteboard without a syntax error in the program? That's stupid. No, if it's a whiteboard problem, you get to write pseudocode. That's the rule, because otherwise it's just annoying. It needed to compile without access to a computer. Well, okay, here's what I would do. If they really wanted to test for programming knowledge that way, I would let you solve it in 2 steps. I would let you solve it in pseudocode on the whiteboard. And if you fail that, then it doesn't matter what the code would be, right? And then after you successfully do the pseudocode, I would say, okay, let's write the actual program now. That would be a sane version of that, but it sounds like that's not what it was. Why not go with binary on the whiteboard? That would be my counter offer to them. Like if I went in, I haven't done a job interview in decades, right? But if I did, like I think the last one was 1998. But if I did, I turn 20 next year. I would say, okay, we'll write out the syntax, but in order to think about the problem and make sure we get it right, let's just pseudocode it out, man. And if they said no to that, I probably wouldn't want the job, because that's kind of stupid at that point. Generate all strings and filter out the good ones. I mean, yeah, I don't know. Did the interviewer ask me about my thoughts on multi-threading? No, they did not. They did ask, stuff about, 3D rendering. How do you figure out stuff about 3D geometry and whatever? Okay. We took the W. Now we're going to go here and we're going to pick a junk character right now, because we just need something that's a 1 character token that is not in use, and I don't want to use comma. We could use like plus even. I want to use something that's totally unambiguous. I mean, we could use question mark. Let's just use question mark for now. Okay, so we already ate this token. So if we get a question mark, we eat the token, and we peek next token. See? It's much easier to think about. Now there's only one active token, right? So did I call it size ident? What was it called? How many backs do we have to do to get to the header file? Size ident. Okay. Does it build? Okay, cool. Okay, let's just do cowabunga-oriented programming. So when we get here and we're doing the instruction selection, if inst for select size ident report info inst this cowabunga. All right. Dude, cowabunga-oriented programming will get you so far in life. Like what we're doing, we're just making sure, because this is a much later time during compilation, we're making sure the information propagates through the system and stays live and all that, right? Oops. You know what? Let's factor this back into a macro, by the way, so it works. Because we inlined all this, but let's like, let's do that again. Because we were just hypothesizing that maybe the macro was messing up the inference somehow, but it wasn't that. So we put it back, so it's factored out. All right. So we've got our cowabunga-oriented programming. Now, so we could do the following operation in the type checker. This is much more like type checking code that I'm going to type here. So maybe we'll move this, honestly. Does type checking do anything for ASM? It evaluates pins and looks at operands. Let's try moving this again. You know what? Because we're gonna do type checking stuff. Okay, so what is inst for select here? It's parse context instructions, same loop. Okay. Oh, and we have inst. All right. So Okay. My comment was wrong. It's not inst for ank, it's inst for... It was inst for select, now it's inst. Okay. True, I don't know. I don't know what to return there. Let's see if that works. Oh, we didn't necessarily save this, so I think we're doing it twice, which is funny. Okay, we're going to run all the tests, and you know what? We're going to take the W again, because that's a kind of major change. But while we do that, while that's running, we're going to pipeline this. So instead of just... Wait. I didn't actually test for the cowabunga happening. Bro, I was doing cowabunga-oriented programming. Okay, we're going to do that. Okay, that's our cowabunga. Maybe we did test that. Dude, I'm getting hungry again. We're going to need to get a snack. We got our cowabunga. Let's just check this in. And move mnemonic resolution to typer. That's really where it should have been. We moved it, and we see we're getting familiar with the system. It's easier to deal with. I didn't have to freak out the way I did. All right, so eval to literal or constant. All right, if consted, else report error size tag must resolve to a constant, but this does not. If it's constant, we're going to cowabunga. All right. Oh. Wait. We're not evaluating this correctly yet. And so I don't know if Ryan really knew. Okay, he did. So it's going into expers there. We're just going to add this to expers. As well. Add the size ident to expers so that it gets resolved in typer. All right, so ask.asm expers.add instruction.size ident, right? Right? Yeah, baby. Okay, so when we get here, so this should work. Now, if we are favored by God, then if I intentionally misspell this identifier now, wait, we changed it. We took away the question mark because we were checking in, but that doesn't make sense because this file isn't getting checked in. If I do this, it should give us a standard undeclared identifier error. Yes. All right, that's great. That is great. Good UI. If, however, we do t, it says it must resolve to a constant, but this does not. Oh, I don't like that. Why do you think that? What if it's size? Huh. Okay, we're going to have to debug that because size is definitely a constant. But like the identifier might not have its scope set correctly. Let's see. I feel like it should. Okay. So, infer types. Okay, because Visual Studio is stupid, it's telling us we're here, but we're really in here. All right. This is just what we have to put up with because we haven't written our own debugger. Okay, so this identifier is not resolved at all. Why not? Why is it not flattened? Wait, what? What? So this is going to have a lot of expers. I'm getting hungry, like I said. Wait, no, it doesn't have a lot of expers. Okay. They're both idents. And we don't have our props file, so we're going to look at both of these. Oh, we might be doing it in the wrong order. Okay, size is our first one and result is our second one. So the reason that's in there is I think just because we use it as an operand, right? Does result get resolved? Yes. But this doesn't. Did I not save the file? I did save the file. Let's just make this a little clearer. I'm going to do this. This is size ident. And this is size ident. Did I not recompile? Like what? I'm pretty sure I did. Okay, so let's see if anything else happens. Expers.add. In flatten, we literally, this is the thing that queues things to get type checked. It's all the expers. So that's fine. What's S32, L0, and C0? Those are the line number and the character number of the debugging range. That's how all this highlighting happens. It goes from L0, C0 to L1, C1 to highlight the expression that we're talking about. So those numbers don't have any bearing on the code running correctly. It's just when we report errors. All right, I'm going to grab a snack. When I get back, somebody tell me what's wrong, okay? Think about what's wrong really hard, the Feynman method, and then tell me. We got pistachio nuts. All right. What am I doing wrong, everybody? Tell me so I don't have to debug it. What's wrong is something that isn't quite right. That is correct. Thank you so much. Send beta keys. If somebody can tell me what code to type that fixes this, they will get a beta key. Before I fix it. Okay, I didn't change this, by the way. That's a mistake. That is not our problem. Dude, we got another Control M. Why is this happening all of a sudden? I even told Visual Studio, you know, it popped open the box that said, should I overwrite all your line numbers? And I said, no. Maybe you have to say yes, and it'll stop it. Oh my God. All right. So this is just going to tell me what I already know, but we're going to do it. Whoa. What? Wait, really? Really? Oh. What I just did isn't going to work because when we parse, oh, yeah. So the thing is, when we parse, that's not the one that we're compiling because we parse it into the macro, but then we copy it out of the macro. And there might be multiple. Let's just look at the line number. Oh, source. That's at line 4. That's not the one we want. The one we want is at line 14. Okay. So, two expressions. That is size. This is the one that we want. It is getting stack added. Does it have weird flags? No. All right, we're going to break in resolve one ident or like inferred types. All right. Let's just see. Does anything weird happen here? Oh, stack add might be a no. This is not set. Okay. Oh, we actually get here. I kind of expected not to get here. Oh no, guys. We actually... Oh, the expers... Oh... Here's the... I know the problem, guys. I know the problem. Yeah, I get a beta code. Note, okay, I debugged for a while, but note that I didn't debug all the way to the problem. But I know the problem now. I just needed this piece of information that this identifier is getting resolved. And that was enough to click it into place. And anytime you can do that, it's super valuable. Because, dude, we could have easily spent another 2 hours tracing through stuff trying to figure out what's wrong. It's so easy to burn that much time debugging. Anytime you can skip debugging time, it's fine. So here's the problem. Remember when I said we are parsing into the macro and then copying it? That is true. If we go look in the copier, remember it copies by value this parse context. But then, and I didn't look at this at the time, but I'm sure it copies the expressions. See? And the reason it does that is because each, like the name resolution in each of these could be different. Like it resolves to a different symbol because like, you know, it's a polymorphic procedure and we called it once with one type and once with another type, right? So like anytime something polymorphs and could resolve, that has to be a different copy. Okay? The problem is, remember I stored by pointer in this parse context the identifier. After we copy, I'm pointing at the wrong identifier. So the identifier is getting looked up and resolved correctly, but I'm looking at the old one that will never get resolved because it's in the macro. And we wouldn't have had this bug if we had the old version of the code where we'd inlined it outside the macro, so I'm glad we kept it in the macro. Okay, so the way we fix this is just by doing the thing I was going to do before, right? Which was wherever that frickin' header file was. Let's go here. No. Yeah. Right? This thing has to be... Let's call it S16. To be an index because the expers get copied. If we weren't... So the other thing we could do is just have the pointer here and not have it be in expers. And then after we value copy this... No, we can't because... Yeah, we would... Okay, we would have to do the thing where we put this on the struct first. So let's not do that. Yeah, so, you know, it may be time to do this rework. Like Ryan had these notes about reworks to do of the data structures, and that would change how I handle this as well. Now, the thing is, he uses U16s for his index. In principle, I'm wasting a bit here, but I don't know. Like, less than 0 just feels cleaner to me than... you know, than putting FFFF in. And these shouldn't be, in principle, you could have a really long ASM with a lot of indices, all right? Like that could happen. These are really small index ranges, so I think we're going to want to convert all this to at least bigger indices, if not pointers later. But we're not going to worry about that right now. We're going to fix the problem. Okay. In parser, when we say size ident equals, wait, that's not. Okay. So when we say size ident equals, index equal asm expers.count, all right? Like that. And then here, asm expers inst size ident index. If ident type is not equal to ident, we got something really wrong. Report ice ident we thought this should be an identifier, but it isn't. Return true. Okay, so that's that. Now we have an ident, and we can do that, and it should be constant. Wow, that was loud. Report. Oh, it's not report ice. It's just ice. Ice, ice, baby. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. I remember seeing one time on MTV, they were interviewing Vanilla Ice, and they were like, "Isn't that really close to that David Bowie song?" And he was like, "Listen, if you change just like one note, you can squeak through and not get sued." And he was really just like, "Yeah, I know this is a slimy thing, but what are you going to do about it?" Cowabunga, there we go, and it is constant, bro. Bro. Okay. Here's what we're going to do, though. Because we have this other member, explicit size. Report error. Cannot specify a size identifier, a size tag. Let's just say size tag if the instruction has already specified a fixed size. Bro, you can't do that. So we're just taking care of that confusion about, oh, okay. Put that down there. We're just taking care of that confusion. Okay. Boom. Cowabunga. Now, note that our program doesn't run because when we get the size identifier, we're not doing it, right? Okay. So, defin is get inferred type constant. If defin is type def type, or no, wait. Yes. Yes, that's right. If constant type is type definition, else ice ident unhandled case in type x64 ASM instruction type tag handling. All right. If it's a type definition, which it I think this is the only possibility. As type definition. This identifier refers to a type of invalid size. The size is whatever. The only valid possibilities are size 1, 2, 4, 8. Okay. Right? Okay. Oh, we didn't put the size. Type arrow size. Actually, this is greater than or equal to 0. A type that does not have a concrete size that's illegal for an ASM type tag, whatever. This is fine. We can work on the error messages later when we know really what's happening. So here we're like, okay, the size is this. All right. Good old-fashioned brute force scenarions. All right, so here we're going to say this is some high-tech stuff that we're going to change later. All right. Bro. Okay. So, something didn't totally connect. So let's make sure we've got all our bases covered. We cowabunga'd. Let's put cowabunga in here. Oh, wait, we have size. Right? We didn't. So, yeah. Because T wasn't working, I just programmed the T version right now. Mr. T. Mr. T is in the house. So, size 4. Okay. Check it out. And you know what that means? That means we could finally do this. Maybe. Cannot specify a type tag if the... Oh. So, okay. The flaw in this plan is I'm overriding the size. See, it's good that we're testing this. I'm not used to the thing that Ryan did, which he said in his own comments he wanted to do it differently. So I'm not complaining. He gets why this is weird. But we're writing into a shared thing, and then we're reading it out the next time. We don't want to do that. And so instead of setting this, we'll go... size. Let's do explicit size. Okay. So we're just gonna write to a thing on the stack here, right? Okay. And instead of writing it in, this is gonna be our local one. And then we're going to look it up there. And it doesn't work at all. What did I mess up? Let's find out. Let's find out. We're very close. Dude, my file... Oh, there it is. This tab system is so bad. All right. This is happening on the 4 bagger, which is the first one. Okay, so we come in here. We don't come in there. We come in here. we've got a size identifier. All right. Explicit size is going to be 0, yes. We're consted. If it's a type definition. It's got a size. Cowabunga for 4. Explicit size is D. Okay. Maybe it's not supposed to be D. Maybe at some point it gets converted to 1248. I don't know. Explicit size, D. So that appears to be working. We didn't want to step into that. Name, size. All right. Let's go back here. Match. Dot size. Okay, so desired is the string, right? bswap.d. Is that not what it is? bswap.d. What is your major malfunction, Lieutenant? Do you not see bswap.d right there? Hash. bswap.d. Oh, it's doing the stir comp. Right, because it's a hash table. So anytime you have a hash table, right, it uses the hash to give you fast lookup, but things can collide. So you compare the key afterward, right? You compare the key, and that will tell you whether you got the right entry. And well, I don't know. Match is bswap. I mean, it's the same. I thought we were going to compile it or do it against the input without the size, but no. Now I'm confused. Return mnemonic. What? Oh, maybe I misread this. Not equal. Maybe I thought that said equal. So it's bswap.d. bswap.d. Bro, it works. What about the second one? Size is Q. Great. Mnemonic. bswap Q. I mean, it sure looks like it's work. Did we just not recompile? Have I been sitting here like a dumbass for 10 minutes because we didn't recompile? Oh. You know, maybe somebody else is reading the explicit size later. Right? But nobody would. I just added that. I literally added that. So why is it not working, chat? bswap.d. Yeah, bswap.d sounds like something Destiny would be into. There is an error somewhere. That is true. That is true. Okay. Okay, this is not actually what we're compiling. Let's look at what we're compiling. You know, I bet it's something else about the shared struct in some way. I bet it's actually not my error. Because here's the thing. Everywhere that we use these, so if we polymorph and copy this guy, we would always only use him in the same size case, right? So like if there was some bad situation. Oh, dude, we're writing out the mnemonic. Okay, here's what's happening. Remember how when we were swapping this with 8, we got a 0? We're still getting 0. The reason is because we're overriding the damn mnemonic. Okay, let's take that out of the parse context. We could move, you know, he had these notes about, you know, moving everything out of the parse context. But for now, we're going to take this out. And then we have to have a frickin'... Wait, no, this is still on parse context. That's not right. We have to have an array of okay. This is kind of annoying. But not totally. Okay, so when we go here to bytecode builder, all right, instead of saying dot mnemonic, we are going to be we're just going to do this. Okay. Oh, wait. Wait. We don't need to store this at all, right? Because, oh no, we do, because, yeah, because this is in typer, computed in typer, used in bytecode builder. Okay. So here we go. We're gonna assert asm mnemonics.count. It's going to be a parallel array is equal to parse context instructions.count. Auto mnemonic equals asm mnemonics I. All right. All right. Okay, so I mean, if we're still using mnemonic somewhere. Wait, didn't I just change that? I thought I literally just changed that. Maybe it was a different line. If we're using the old thing, it's fine because we deleted it out of the Parse context. I thought we would just cruise by without worrying about this problem. But we didn't. We got bit. And it's not that surprising. And again, it's just like I'm not used to AST nodes having pointers to all this shared data. Okay. Auto mnemonic. It's like Johnny mnemonic. It's a combo between Johnny mnemonic and Inspector Gadget. All right. Assert ast asm mnemonics.count is equal to I. Ast asm mnemonics.add mnemonic. See, just understanding what your program is doing is super valuable. Like having that model in your head. So there we go. We have added the feature, guys. Like, how awesome is that? What makes the word swap different? It's just like, I assume that that's the only because x86 is so screwed, right? Let's look it up. B-swap. We'll look at Felix Coultier. That's always the top hit. Cloutier. Oh, God. Oh, it's so bright. Okay. So he only has 32 and 64, which would be D and Q. So, dude, he doesn't even have a W. So, like, there's a secret B swap, maybe, that's not even listed here. I mean, it works. We're using it and it works. Oh, to swap bytes in a word value, use the exchange instruction. So what's happening is, in our instruction tables, we're pretending there's a B swap W, and we're using exchange, and exchange only goes to A as the output, right? Yeah, see, the 16-bit only goes to A. It's like, welcome to x86, dude, right? There's like all sorts of stuff like this. Wrong, look down the list. XJig. Oh, well, there's, okay, I mean, there's other, okay, so this is like the old one. The way this often works is there was an original exchange, and then they were like, this sucks being pinned down to specific registers all the time. So you end up down here, right? Honestly, though, in code like this, I would kind of rather not pretend that it's B swap. Oh, no, but okay. These won't work. These won't work because, well, okay. There's some instructions that like swap AH with AL, for example, right? Or, you know, there's instructions that do AH, AL kind of stuff, like operating within the same word. And those are out of fashion, but they still exist. And I think that's what this is mapping to, but I don't see that in this table, right? I don't see an AH version here, but these require two different values, right? Like this is like two, if you have it in two different registers. That's not what this is doing unless it's literally doing that behind the scenes. I don't know. We could look at the output assembly, but I don't want to do that right now. x86 is insane. Truer words have not been spoken this evening. Okay, so this is the T version. We also want it to work for size. So I'm going to do that there. And this won't currently work. Oh, whoops. I also said dot. You know, we could change it back to dot eventually if we... Like, if you don't say DWQ, etc., and you just say 1248, then we could just have the dot, and if it's an identifier, it's, you know, one of these tags, right? You know what I'm saying? And if it's a number, then it's a size. Like, that would be cool. Okay. For some reason, yeah. So this doesn't currently work, but we're not erroring on it because I think we just didn't finish the code. So let's go back here. This would be in typer. So if it's a type, we do all this. If it's not a type, we don't do anything, right? If it's a literal, we're going to do a thing. Else, we're going to report an error. Size tags must be of type integer. For now, it's just integers. We won't even do floats yet because we're not trying to do this on vector instructions yet. Must be types or integers. Instead, this is of type whatever. Type name. All right. Type name is interp type to string, def and defer, free type name. Okay. Oh, not if it's a literal. No, it doesn't. It doesn't have to be a literal. So we're going to factor this out so we don't, you know, do it multiple times. So we're going to say type arrow size here. All right. We got to put interp here. Interp. And I don't remember if these are signed or unsigned. Oh, this is a big function. Let's just go to the top of the file. I forget what the other arguments are. I'm going to do that. Get asm size and ident and a size. Is it S64? I don't even know. We'll put that just for paranoia reasons. And we can change these to 1, 2, 3, 4 later. It's fine. Okay. Didn't work. Let's see. Let's see. So we don't know if it didn't work. So let's change it back to the old one because we don't know if it didn't work because we factored it wrong or because we're just not doing the right thing for integers. And I think it's probably the latter, but let's see. Yeah, so it works if we change it back to the type. So we're just not doing the right thing for integers. That should be easy. Okay. Defin size is 8. What? Wait, what? Oh, because size. No. We don't want the type. We want the value. We want the value. Okay. Let's do it this way. If it's a literal, if literal value type is value number, right? Else, whatever. We need to get, there's like a size from number flags, I thought. No, I don't see that. We'll figure it out. If that, we do something. In fact, we can hard code it right now and just say explicit size equals W. Right? We just want to make sure that we're just being very incremental about this, okay? And here we just say we report an error. Size tags must be types or number literals. Number literals. We're going to let people squeak in a float for now. All right. Value number. What? Is it literal number? Yeah. All right. Hey, it works, but only because we did this. But see how powerful that is? That's great. Now we just have to replace this. So we have value flags. So I'm looking for somebody who gets a size from value flags. Oh, is it from numeric flags? We could do that. I mean, just to be paranoid, so... Okay, so... let's just look for someone who does... So, number flag 32-bit. Bytes from flags. See that? See that? Bytes from flags, number flags. All right. Boom. Literal. What was it called? Value flags. I should use consistent terminology. Get ASM size tag. All right. Here we go. Cowabunga size 0. That's not good. That's not good. That's not good at all. Okay, let's... number flags. They're not 0. Oh, no. It's not hardened. Like 1 means it's an implicit S64, and like I guess we're not getting that. But I thought this would handle that. Like, what happens when we go bytes from flags here? Do we not get 8? No, we literally don't. We literally don't. Do we do anything else where we manually... Oh, you know what? Let's just see when we're here. No. Wait, I'm doing the wrong thing, guy. I'm still doing the wrong thing. I'm still doing the wrong thing. Dude, programming languages are confusing sometimes. Um, I'm still trying to reason about the type of the thing. We don't want that. This is a different way of talking about the type. We don't want that. We literally want... Let's just make this integer literals right now. Floats, not allowed. All right. So... do we have like as S64? But not, oh, we do. We do as S64. Yes. Oh, that's what we want because we want to read the actual number. I keep getting sidetracked. So I'm going to go size is as S64 literal bits from flat. No. Yes. This part, number flags. All right. Like that. As S64 identifier not found. It's in constexpr.cpp. Well, we're going to move it. Move it or lose it. Move it or lose it. Thank you, C++, for making me randomly, arbitrarily move something that was completely unnecessary. Okay. Wait, did I change it back? No. Yeah. So here we're using an integer literal. Here we're just using a type. And both of these work. Let's make sure before we change anything, let's make sure that all our tests pass. We can also so I want to put a pretty long explanation. So that people understand, right? And I think pop count is good. Pop count is good because these three are the same, but this one is different. So I'm going to put this in. I'm going to say, it's going to be quite a long explanation. We like typing long explanations because it makes people feel like we did a lot of work in the patch notes. Okay, ASM now supports controlling instruction size, or how would you say it? Instruction someone tell me how to say that. By using variables that come in from a the higher level language, either using a type to size the operation or using an integer literal For example, in modules bit operations, right? The code for pop count had the following ASM. Boom. That's a little too indented, but we'll deal with that. Okay. This has a lot of duplication. This is very verbose. Now you can compact code the code as follows. This is the new version. I mean, see, isn't that nice to go from this to that? The question mark is the syntactic indicator that we are using a variable or a higher level language identifier to indicate the instruction sizing. Eventually we will probably change question mark to dot, but this will require some other changes to people's code, so we will wait on that for a while. Instead of, in the above case, size is a constant integer literal. The sizing tag must always be a constant. It must be known at compile time. Size is a constant integer literal. Instead of taking the size, you can just use the type instead. So we're going to go if size of, this is probably what we're really going to do in this, t is equal to 1, else pop count t. Isn't that cool? Okay, who had suggestions about now supports defining operand size prefixes. It's suffixes. Operand size. Yeah, I guess it's operand size. Kind of, I mean, yeah, it is. Okay. So that's pretty cool. I mean, I think the question mark is ugly, but like I said, we're gonna change that later. Don't you feel like you got a good update of the compiler when the patch notes are this long? Yes, you do. Okay. This is very, let's say, redundant instead of verbose. Could use a caret. Yeah, you could use all sorts of things. Is caret better? I mean, it's less ugly, but is it better? Probably. Probably it's better. It's just everyone in Finland is going to complain, right? Harder to type. Yeah, yeah, we've already got people complaining. It's fine. Okay. So let's change our code here. Let's see what happens. So, you know, we sort of, I mean, we have size less than or equal to 8, but what if it's 6? We like silently fail. But we won't silently fail now. Okay, so let's do this. Pop count question mark T. And that's great. And for anything besides 1, we'll get here and okay. We're just going to do that. Do we think that whoops, I saved it. I saved it with this in there. I hope I didn't mess it up in other ways. All right. Count 22. Do we believe that 22 bits are set in Cafe Babe? I mean, it seems about right. I don't know, 22 out of 32? That's a lot of bits. That's a lot of bits. All right, let's do this. Bit scan reverse. We're just going to do this in both of these. Bit scan forward. Just really locking it down. All right, bit scan forward. And, you know, we have tests for these, so that's great. Look at that, dude. Oh, but it's not comma T, it's question T. And bit scan reverse. All right. Else. Boom. Isn't that more nicer? It's like half the code size for these ASMs. Byte swap in place. Okay. So we have a bit operations test somewhere, but it's not in the module. So we're just going to run all our tests. And hey, and we can use the official byte swap instead. So here, and okay, we've got duplicate asserts here. So let's not do that. Like this text is like kind of redundant. Like, can't you just fucking, I don't know. So like this assert is redundant. We put it above. That was pretty weird. I mean, I guess we don't need the extra parens here. And that's pretty cool. There's definitely other things. But I think what I want to do is take the W on these, assuming it works. And then we'll just go through and look for other assembly. Oh. I broke something. Oh, we got to take the cowabunga out. By the way. Let's at least no check in that, because it might help us debug something here. We've got a problem. So we're actually asserting that the answer's wrong? Let's see which one we're calling. Tests, features, intrinsics. Byte swap. All right. What did I mess up? Oh. Okay. Let's... Is this the same? What am I doing here? Maybe it's bedtime. Oh my God, Becky. Look at her butt. Okay. See, we even saved. There we go. Chat caught it. Thank you, chat. If only I had been reading chat. I was busy cowabungaing. Yeah. This is great, guys. Like, The assembler is definitely non-trivial. We had a few problems, but like we're 4 hours into the stream and we spent an hour and a half talking about countries and states. Right? So like it could have been that it took days to do this and it didn't. We are favored by God. The secret, though, is everyone's favored by God. Oh, we got to take the cowabunga out. Oh, we got to take the cowabunga out. Cowabunga. No, Terry Davis certainly believed there were certain categories of people who were not favored by God. Okay? I've hardly seen any of his footage, and even I know that. Look at it, dude. This is running with our new code. How awesome is that? How, like, that's so cool, dude. I mean, it's taken us a long time to get to this point, and I wish we had done it faster, but we are at this point where we are today, now. We are being here now. We are being here now. So, what next? We take the W, that's what. And then we'll just spend a little more time converting some routines. Add the ability to do higher level size tags in ASM. We'll just do some assembly stuff. So I think let's double check the bit operations. I believe we got everything in here. bswap question mark T. Okay. How about atomics? Atomics from the David Lynch Dune. So this is just a straightforward like I think we want to just do right. So we're just going to do question mark T. Just like that. I mean, that's a lot. That's a lot more compact. Yeah, I don't like the question mark. The question mark makes us feel like we're not sure what's going on. But that's fine. We're going to change it. Why does bit test and set not handle? Like, we don't need all those strings in people's programs. Lock BTS W, D, and Q. So again, this is just that. That's so much better, guys. Oh my goodness. It's so much better. All right. Lock X add dot. You know what? We don't need to do that assert anyway, because we'll get the error on the instruction, because the instruction says a size has to be 1, 2, 4, 8. So let's just try, you know, freeballing it. Actually, though, the backup implementation. Oh, it'll probably also, yeah. All right. Like, we don't even need size, dude. Like, if this is going to assert, it's literally that. That's so much better. Oh my God. Also, we're doing is atomic scalar, so it's covered anyway. Yeah. But, like, we're not even using size, dude. Like, this is so much better. This makes me feel a lot better about inline assembly. Okay. Sure hope all this works, though. Yeah, this is atomic scalar is already enforcing the size anyway. Okay. Yeah, I like these ones that are clean. Okay, so let's stop now for a minute. Pause. Because we could have broken all sorts of things, so we're just going to see if things still go. How do you test your atomics? We just have a bunch of tests. And we run the game. Whoops. We don't actually have tests that look at the executable right now and look at the binary. We just make sure the results work. And like, okay, are you sure it's atomic? Well, I mean, I guess not really. Our tests are probably not testing very hard that things are really atomic, although we do have some. We do have some that are very spammy, and they would just fail if locking was not right. That is definitely a thing. All right, let me do one more. Dude, that's so much better, dude. All right. Oh. We're just going to let this ride out. And, yeah. So, what other places do we have ASM? Atomics, we did that. Bit operations, we did that. Machine x64, we didn't do it. let's do this. Let's tell people we used this new ASM feature to cut down on verbosity in modules bit operations in the following modules: atomics, bit operations, machine x64. Hopefully we did not introduce bugs. Sorry. Okay. Machine. The machine. I'm the machine. Right? That's my famous story that I told on Joe Rogan about being the machine. Maybe we're not going to find things in machine x64. Ah, we got this. No, those are prefetch T's. That doesn't count. Yeah, you know what? We don't do anything in machine x64. Great. Hey, look, we passed the tests. Random. I don't think that's going to have any of this, but let's see. Yeah, this is just doing, you know, big multiply. Int 128. Apollo time definitely doesn't. We just looked at that, this stream. I don't think int 128 will have this. Yeah, it's just constant size stuff. Basic print. Yeah, this is like for SIMD, which is turned off right now for some reason. Default allocator. Oh, there's some D and Q stuff. Let's see. No, those are all hard-coded. We could probably refactor those to not be hard-coded, but that's not our job right now. He's just using pause. Memory? What is memory? The hell is this? Oh, it's like... Okay, yeah. It's like different memcopy candidates and stuff that are faster by doing a bunch of stuff. Okay, yeah, this doesn't have that size polymorphism. I forgot we had this. Yeah, all these are... They're not going to have the thing either. Meow hash. I don't... No, that's not going to... Why does meow hash have so many ASMs? I guess they're just a bunch of small things in macros. Yeah, this is not going to have size polymorphism either. Yeah, we might be done. We're done. So it's just those few files. It's a bunch of instances in those few files. Maybe also Sokoban, but that's not my job right now. In just these. Okay. Shorten some asm with the new size polymorphism feature. Typoed that word. Okay. I mean, that's great. That's further than I really expected to get tonight. Did I remove the unnecessary size asserts from bit operations? I think I did. No. Oh, well, these are actually necessary because so we're handling things in slightly different ways. Here we don't have a modify proc that's asserting that it's, you know, a scalar. We could do the same thing here. However, I kind of want to experiment with handling it different ways and just see how we like it. Because the thing about the modify proc is it's a pretty expensive mechanism. And I think it'll only fire once per type, but I still, like, I kind of don't want to do that. I would almost rather have a type restriction here where you could say, like, integer, who knows, like, you know, something like that, right? We don't have that right now. And I, you know, but whatever. Like, if we did that, it would get rid of the need for this and the modify proc, right? So that's kind of what I'm thinking long term. Why not change p add q for add? Where was p add q? I don't know where that is. What's dot y? That's for SIMD vector stuff. I think it's one of the vector sizes because, yeah. In the meow file. Well, don't ask me. I didn't write this. Casey wrote this, so I don't even know what p add q is. All right. I think. Oh, so you're saying why don't I just add with the size? Because there really is no size polymorphism here, so I don't know why I would obfuscate the fact that these are all just full wide operations, right? That's not a good idea. Let's raid somebody. Dude, we streamed for like 9 hours today or something. And I worked off stream, of course. Who we got? Someone's got crabs. Why do people who have crabs advertise that they have crabs? Is it about consent? It's like, look, man, if you get with me, you're going to get crabs, right? It's like a good thing, I guess. I don't know. I don't know why. I don't know why they do it. But they just like to advertise that they have crabs. It's just, it is what it is. All right. Do we see anything good? Lead code with Arrested. Wait. Oh, she's watching Arrested Development. I thought the programming was going to involve Arrested Development in some way. First stream. Is she shopping? Like, what's going on here? Card type. She's doing, what is TSX? TypeScript X, right? What is TypeScript X? All right. If she's not lying about her first stream, be very kind and supportive of the TSX, all right? Thanks, everybody, and I'll see you later on. Be very, very polite and kind, please.